What's up, everybody, and welcome back to another video on SAT Math from the Scalar Learning Channel. This one is how to solve the hardest digital SAT math problems that are currently available through the College Board. So without further ado, I'm going to jump through the hardest problems that I could find across all 6 practice tests that have been officially released from the College Board. I'm going to show you exactly how to solve them and also give you tips on how to solve problems that are like these when you do encounter them on the real deal. And just to mention, if you are studying for the digital SAT, make sure to check out the SATcrashcourse.com. I've officially partnered with them, and I do recommend using their practice tests. They have 10 practice tests that are currently available. You can sign up using the code SCALAR, all caps, for a 20% discount. Without further ado, let's do it. The circle shown has center O, circumference 144 pi, and diameters PR and QS. The length of PS, arc PS, by the way, which is this right here, is twice the length of arc PQ, which I'll put in green like so. What is the length of QR? And QR, I'm going to put in red. So since these are diameters, the things that we know is that they cut this circle right in half, right? So what that means is this is 180 degrees. I'm talking about arc measure, and so is this, right? So what we can then say from there, since I know that PS is double whatever PQ is, right? If that's X and 2X. If we're just talking about arc measure, I can say the two of them together, since they're cut out by a diameter, they're going to equal 180 degrees. So we can start to get the arc measure. That's not different from arc length. The arc measure for both of these arcs. So 2x plus x is 3x equals 180, which means if we divide by 3, x is equal to 60. So this is 60. This is 2 times 60, which is 120. Now, likewise, since this is a diameter here, okay, we also know that this cuts out 180 degrees as well, which means that this arc measure up here, RQ, plus 60 has to be 180, meaning RQ is also 120 degrees. Now, this is very important because we can now use this to calculate the length of arc QR, okay? Now, the first thing you want to recognize is that our central angle is going to be equal to the arc measure that it cuts out, right? When we've got this nice central angle coming from the center, which means that this angle in here is 120 degrees. And why is that important? Because the formula for arc length, okay, that's different from arc measure in degrees. Arc length is equal to central angle, which in this case is 120, over 360 times 2 pi r. And where does 2 pi r come from? Again, that is circumference, right? We're taking a piece of the circumference. Now, since we know that this represents circumference, right? Well, they give us the circumference of the circle. So I don't have to go through the process of actually trying to find the radius. I can just literally plug and chug like so. So 120 over 360 simplifies to 1/3. I'm going to write it down here. And I'm going to replace 2 pi r with 144 pi, right? And last but not least, 1/3 of 144 is going to be 48, right? 48 times 3 brings us back to 144. So the answer is 48 pi, which means B is the winner. That's how you do it. Done. In the xy plane with equation 2y equals c for some constant c intersects a parabola at exactly 1 point. If the parabola has equation y equals negative 2x squared plus 9x, what is the value of c? So first of all, with an equation like this, I immediately recognize this is like a horizontal line, right? Because it's y equals some constant. Because if I divide by 2, I've got y equals c over 2. And I already said c is a constant. So we got some horizontal line. Now, the only way this horizontal line is going to intersect a parabola at exactly 1 point is if it touches it right at the vertex, right? Anywhere else, if I have it below, it's not going to hit it at all. If I have it above, it's going to hit it twice, right? So we know it's got to be right on that vertex. And the reason why that's helpful is because we can then figure out what the value of the vertex is from this equation, and that y value is going to be equal to this c over 2. Because again, that y value of the vertex has to match up with this horizontal line. So how do we figure out the vertex? Obviously, you can plug it into Desmos, and we can immediately see where the vertex is, or we can use a little shortcut, depending on your preference, and we can say, well, my vertex is going to be at negative b, which in this case is 9, over 2a. and my a value is whatever's multiplying the x squared, which is -2. So we got the negatives are going to cancel out. We've got 9/4 is equal to x. That's my x value, my vertex. To get the corresponding y value of the vertex, we're going to plug it in up here. So we got -2 times 9/4 squared plus 9 times 9/4. And we can simplify this to be, that's 81/16 times -2 plus 81/4, right? Simplify this becomes an 8, and then we got -81/8 plus, let's double this up to get common denominators, 162/8. We add these together and we get 81/8, okay? So this is my y value. So that means 81/8 must equal c/2. Now we can solve for c by multiplying both sides by 2, and we get c is equal to 81/4, right? We multiply by 2, and we're basically canceling this out to a 4. So our answer is 81/4. That's how you do it. Done. Dataset A consists of 10 positive integers less than 60. The list shown gives 9 of the integers from dataset A. The mean of these 9 integers is 42. If the mean of dataset A is an integer that is greater than 42, what is the value of the largest integer from dataset A? So for this one, what I'm going to do is I'm actually going to use Desmos. I'm going to show you how we're going to do this now. So we see what these 9 numbers are, but it doesn't really matter because when we're talking about a mean, they already gave us the mean of these 9, which is 42. So I can add these up in Desmos, but I also know that the total is equal to 9 times the mean of those nine numbers, meaning 9 times 42, which is 378. So the reason why that number is important is because we know we're adding a 10th number and then we're taking the average, right? And so currently we know that this C value is less than 60, but we're trying to find the value of it where we're going to get an integer mean, right? You see right here, we're getting a decimal value. So again, we know that the mean with this 10th number must be greater than 42. So that means our C value here has to be greater than 42 as well. So when it is 42, we see we're exactly back at that mean of 42, but we need to get it up to probably the next integer value at least, which would be a mean of 43. So let's start plugging in values for C. We see these are still giving us decimal values. It's kind of incrementing by 0.1 every time, right? We go to 9, then we got 50, 51, and 52. Now, this has got to be the answer because it also says the last value is less than 60, and we can see every value leading up to 60 is still giving me decimal values. So that means 52 is the winner. That's the largest integer from dataset A. Boom, done. In triangles LMN and RST, angles L and R each have a measure of 60, LN equals 10, and RT equals 30. Which additional piece of information is sufficient to prove that these are similar? So we remember our similarity theorems that are applicable on this test. And we've got angle, angle, we've got side, angle, side, meaning proportionate side, angle in the middle, and another pair of proportionate sides, or side, 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 meaning every set of sides is proportionate. So right now, I'm going to draw out these two triangles, and all we know right now is that L is 60 and R is 60, which is stated right here. We also know that LN is 10 and RT is 30. So now we see that we have a potential side angle side relationship if I can show that these two sides have a 1:3 ratio just like these two sides. So we're going to see that first if there's any information about ML and SR. And it looks like there isn't, right? This has to do with MN and ST. This has to do with MN and ST as well. So that's not even going to give us our side angle side. So these two aren't going to do anything for us. Our other option, since side angle side is out, and we definitely only have one set of sides, and these two are referring to angles, is angle, angle. So hopefully one of these gives us angle, angle. So if we know that M and S, which are corresponding angles, right? And how do I know that? Because of the order that these points are presented, right? L corresponds with R, M corresponds with S, etc. So it's saying that M and S are 70 and 60. This one would tell us that they're different, but corresponding angles need to be equivalent in order to get this angle-angle similarity. So C wouldn't make sense. D has to be the winner. But now I'm going to show you why. If M and T are 70 and 50 respectively, they're saying M is 70 and T is 50. Okay, why is this enough for angle-angle similarity? Because I still don't see two angles that are congruent, because 60 plus 50 is 110. That would make the remaining angle here 70. And that means now we have angle, angle, similarity, which allows us to prove they are similar. Boom, done. The function g is defined by g of x is equal to f of x plus 5. For what value of x does g of x reach its minimum? So I'm going to show you how to do this actually using a combination of applying what this precisely means and Desmos. So let me show you. So what they're saying is g of x is equal to f of x plus 5, meaning what they've done with every position with x, they're going to replace it with x plus 5. So let's plug that into Desmos now, and then we're going to use that to find our minimum value. So this is f of x right here. And to get g of x, we're going to replace each x with x plus 5. So you see how I'm just literally plugging it right in like this into Desmos. And now I can see the minimum. It's right here. And what was it asking? For what value of x does it reach its minimum? It's right there at -13. So A is the winner. Done. In the given system of equations, A is a constant. The graphs of the equations in the given system intersect at exactly 1 point. What is the value of x? Okay. So we know that they intersect at exactly 1 point. So what do we do with that information? Well, the first thing is if they do intersect, we can set them equal to each other, and that's how we're going to eventually solve for x. So let's do that first. Now that we get to this point, we're going to do our traditional steps, meaning we're going to set everything equal to 0. So we got 2x squared. I'm going to minus 3x from both sides like so. That's going to give me negative 24x, and I'm going to minus a from both sides like so, right? And we got boop, boop. We've got plus 64 minus a, and all of this now equals 0. So we need to find the value of x for, the solution. But the problem is we got a in the mix. I don't know what a is still, but here's the interesting part. It says that a is a constant such that these two intersect at exactly 1 point, meaning with this current quadratic that I've now created, I should have a discriminant of 0, okay? And what's the discriminant again? If this is a, b, and this whole thing is c, it's b squared minus 4ac. And again, for one solution, it must equal 0. So b squared, 24 squared is 576 minus 4 times a, which is 2, times c, which is 64 minus a, is equal to 0. All right, and this will allow us to solve for a. So 4 times 2 is 8. 8 times 64 is 480 plus 32 is 512. So we got 576 minus 512. And then again, that negative 8 is going to distribute to the negative a, which is plus 8a is equal to 0. 576 minus 512 is 64. Plus 8a equals 0. 8a equals negative 64, and divide by 8, and a equals negative 8. So a lot of people might make the mistake of choosing option A, but it's not asking for the value of a. It's asking for x. So if we know that a equals negative 8, now we can plug it in here, right? Replace this a with negative 8. So 64 minus negative 8 is 64 plus 8, which is 72. Okay, so now we have minus 24x, and then we got 2x squared. And again, we're solving for this equation. We're finding the value of x when this whole thing equals 0. So now we got a nice quadratic. First, I'm going to divide everything by 2 to get rid of that leading coefficient. Let me make some more room up here. So we divide everything by 2. I've got 0 is equal to 1x squared minus 12x plus 36. Now we can see that this factors nicely. It's actually a perfect square, and it becomes x minus 6 squared, right? X minus 6 times x minus 6 gives us this, which means our solution for x is 6 right here. So C is the winner. That's how you do it. Done. The function f gives the temperature in degrees Fahrenheit that corresponds to a temperature of x kelvins. If a temperature increased by 2.1 kelvins, by how much did the temperature increase in degrees Fahrenheit? So for me, the easiest way to figure this out is to use a combination of Desmos as well as two different x values, right? Because x represent Kelvin. So we want to know how much does Fahrenheit go up when Kelvins goes up by 2.1. So I'm going to start, I'm going to try and do this as smart as possible in terms of trying to make this as the least amount of work possible, right? So my first value for x, I'm going to actually plug in 273.15, okay? And the reason why that is so good is because I can literally do this first calculation mentally, right? We'll use Desmos for the second one, plus 32. So when I plug in this for x, that is zeroes out, and we get a Fahrenheit value of 32. Great. Now I want to know what happens when x goes up by 2.1. So now it's going to be 9/5 times 275.25, right? Adding 2.1 to that. And now we're going to evaluate and see what this is, right? Obviously, this minus that is 2.1. That's the change. And then now I'm going to use Desmos to finish it off. And here we get 35.78. So the new value is 35.78. So how much did the temperature increase in Fahrenheit? It looks like it went up by 3.78, which means A is the winner. Done. The table gives the coordinates of 2 points on the line in the xy plane. The y-intercept of the line is this, where k and b are constants. What is the value of b? So the first thing to recognize is if this is a line, like what is my y-intercept? By the way, I don't know if this is a positive or negative slope just yet. I'm not even thinking about that, but just so you can see, right? The y-intercept is right here, and x is always 0 at the y-intercept, right? Whatever that y-intercept is. And that means k minus 5, therefore, which is the x value of the coordinate for the y-intercept, is going to equal 0. So now I can solve for k. I can add 5 to both sides, and k equals 5. So again, step by step, we're working through this problem. First, figuring out what k is. That means this coordinate is 5, 13. This coordinate is 5 plus 7, which is 12, negative 15. Now I have two awesome points. I have 5, 13, and 12, negative 15. Now again, what am I solving for? I'm solving for b, which is the y value right here of my y-intercept. All right, so we can solve this now first by calculating the slope and then creating an equation for this line in point slope and then figuring out what the y-intercept is as follows. So let's subtract down and find the slope. 13 minus negative 15 is 28 over 5 minus 12, which is negative 7, which gives me a slope of negative 4. Now to get point slope, let's use the top coordinate. We're going to say y minus 13 equals negative 4 times x minus 5, okay? Now, to find the y-intercept, aka the b value, I'm just going to put this back into slope-intercept form. You could also plug this into Desmos, so I'm going to show you how to do this both ways. So first, distribute. I got y minus 13 equals negative 4x plus 20, and then add 13 to both sides. I get y equals negative 4x. 13 plus 20 is 33. So that's my y-intercept. That's the answer. But now I'm going to show you how to do this in Desmos. So just putting this in point slope as it was, and confirming that we have 5, 13, 12, negative 15. So there's 5, 13 approximately, and here's 12, negative 15. Now we can just look for that y-intercept, which of course is 33, as we already figured out. So there we go, double verification. 33 is the winner. Done. One of the factors of this is x plus b, where b is a positive constant. What is the smallest possible value of b? So what this is telling me basically is we need to factor. First thing I'm going to look for is a GCF, which I do have as 2x. So I got 2x, and then inside I've got x squared plus 21x, right? Dividing every term by 2x plus 104. Now I want to see if I can factor this quadratic, and I can, right? What two numbers multiply to 104 and add to 21? That's going to be 13 and 8. Both positive, right? Because we got plus here as well. Okay, and that's how you factor it. So now that we've got it nice and factored, we can say that the smallest possible value of b between 13 and 8 will be 8. That's the answer. Done. So this one is quite crazy, right? It looks really intimidating. It says C is a positive constant. Which one of the following is solutions to the given equation? Meaning, which one gives us our value for X? So when you first look at this, you might not be sure what to do. But what I always say in a case like this is simplify to whatever extent you can. And I see we've got these common denominators on the left and right hand side. What I think would make a lot of sense is we can bring these guys together, right? So I've got x squared over square root of x squared minus c squared over the square root of x squared minus c squared, right? And this equals 39. Now I can bring these together since I have common denominators. We got x squared minus c squared over square root of x squared minus c squared. Okay, so you might still be like, well, I don't really know where to go from this, but remember, you can kind of say, well, this whole thing, since there's no exponent, it's really to the first power. And square root, if you remember the rational exponent equivalent, is really to the 1/2 power. So guess what? We got common expressions under different exponents in division, and when we have division with the same expressions under different exponents, we can subtract the exponents to simplify. So 1 minus 1/2 is 1/2. So we get x squared minus c squared to the 1/2 power equals 39. Okay, now all we got to do is isolate x squared. So first I'm going to square both sides, right, to get rid of this square root or 1/2 exponent, right? So we're going to square this side. I'm not going to evaluate it because all my answers have 39 squared as is in the answers. These are going to cancel out. Now I have x squared minus c squared equals 39 squared. Now I'm going to add c squared to the other side. X squared equals 39 squared plus c squared. And last but not least, we're going to square root both sides. Boom, boom. And I've got x equals plus or minus square root of 39 squared plus c squared, okay? And the only one that works is going to be option D. Now, again, they have a different order, right? C squared plus 39 squared, but of course, addition, we can move those pieces around. It's still the same thing. D is the winner. Boom, done. In the given quadratic, a and c are constants. The graph of y equals f of x in the xy plane is a parabola that opens up. And notice as they're describing it, I'm drawing it out, right? Opens up and has a vertex at h, comma, k, where h and k are constants. If k is less than 0, meaning k is negative, and therefore this is below the x-axis, okay? And then it says f of negative 9 equals f of 3, okay? So the function value when x is negative 9 is the same as the function value when x is 3. Which of the following must be true? Well, what that tells me, okay, I don't know where those are, but I know that those are basically saying those are sister points, right? At negative 9 and 3, meaning they're equally as far from the center line or the axis of symmetry as the other, okay? So negative 9 and 3, in the middle of them is going to be my vertex. So what's in the middle, aka what's the average of negative 9 and 3? Negative 9 plus 3 is negative 6 divided by 2 is negative 3. So that means my vertex is at negative 3, comma, k, where again, k is negative. Okay, now we know all this. We also know that our y-axis is somewhere here, right, between negative 3 and 3. Now we can start to figure this out. So I know that my vertex is negative 3k, and because this is in standard form, the cool thing about this is I know in standard form, if this is a, b, and c, negative b over 2a is equal to the x value of the vertex, meaning that's equal to, in this case, negative 3. Now, I know that b is 4, but I don't know what a is. But because of this equation, I can now solve for a. Multiply both sides by 2a, negative 4 equals negative 6a, divide by negative 6 on both sides, and the negatives cancel out. We get 4 over 6, or 2 over 3. So a is 2/3. So is a greater than or equal to 1? No, that is wrong. It's 2/3 is less than 1. So that means b and c are out. So the question is a true or are neither of these true? Meaning, is c negative? So to figure this out, what I'm going to do is I'm going to rewrite this knowing that a is 2/3. So I got 2/3 x squared plus 4x plus c. And we're going to play around with values of c in Desmos. So as you can see, right, no matter what I do with c, if I make it negative or bring it up to be positive, it doesn't really matter, except for c can't go above that value, can't go above 6. Because if it goes above 6, now all of a sudden the vertex is, the y value of the vertex is positive. It said the y value of the vertex is negative. So it can be as high as 5. So that tells me that c does not have to be less than 0, but it can be less than 0, right? It can be down here, and that still works just fine. But anyways, the answer therefore is D. That's how you do it. Done. Which of the following are solutions to the given equation where a is a constant and a is greater than 30? Okay, so for this one, we've got 3 different options. And if we're trying to find solutions, I already know that 29 has to work. And the reason why is because when I plug in 29 for x, this becomes 0 and this becomes 0. 0 times anything is 0. So we're going to end up with 0 equals 0, which is true. So that means 3 is definitely legit. This one does not include 3. That one is out. Now we're wondering if a is a solution, right? Knowing that a has to be greater than 30, right? So in this case, if I plug in a on the right-hand side, I get a minus a. That would be 0. 0 times anything is 0. On the left-hand side, I'll get a minus 29. Now, since a cannot be 29, it has to be 30 or greater. These two are not going to be equal to each other. So that means a is no-go. So anything with 1 is out. So goodbye B, goodbye D. And it looks like C is going to be the winner. But now I'm just going to show you why 2 is correct. So a plus 1. So let's plug it in for x, and I'll just show you what it looks like. So I'm going to replace that with a plus 1 minus 29 equals a plus 1 and then minus a times a plus 1 minus 29. So what you see happening here is the a and the negative a cancel out. Then I have 1 times a plus 1 minus 29 gives me a minus 28. On the left-hand side, 1 minus 29 is negative 28 as well. These two are the same. That works. C is confirmed. Done. What is the positive solution to the given equation? So the reason why I included this problem is because you might look at the absolute values and be a little bit confused as to how to approach this. But what you need to recognize is at the end of the day, these two are the same expressions. So if I have 2 of that expression plus 3 of that expression, I now have 5 of that expression, okay? And now I can isolate and solve like any other absolute value equation, divide by 5. Absolute value of 4 minus x is equal to 5. Now we can split, and then I've got 4 minus x is equal to 5. 4 minus x is equal to negative 5. That's when we have absolute value. We always bifurcate or split, right? Now I'm going to simultaneously add x and simultaneously subtract 5 from both sides. X equals negative 1. Over here, add x, and then add 5 over here, and we get x equals 9. So these are our 2 solutions, but they want the positive solution, so 9 is the winner. The other way we can do this is using Desmos. I'm going to show you how now. I'm going to plug the left-hand side in for one function and y equals 25 for another one and see where they intersect. So now I've plugged in both functions. We just have to find y equals 25, which is up here. And the solutions are these intersection points. So I see a solution here at about negative 1 and over here at 9. And that's exactly what we found algebraically. So again, double verified. 9 is the winner. Done. The function f gives the value in dollars of a certain piece of equipment after X months of use. The value of the equipment decreases each year by P% of its value the preceding year. What is the value of P? Okay. So if I want to find this value, this P%, what I have to do is, since this is X is the number of months, I need to figure out what that percentage drop is when I plug in 12 for X. So plugging in 12 for X, I get 12 over 12, which is 1. Okay. So for that 1 year now, I've got 0.64 to the 1 power times 5,470. But this right here tells me all I need to know, right? If I'm going to be taking 64% of this value, right, how much am I losing? Well, if I'm starting at 100% and I've got 64% left, I dropped 36%, meaning that P, the percentage that it decreased each year, is 36%. C is the winner. Done. The function f is defined by the given equation. If g of x equals f of x plus 2, which of the following defines function g. So what they're doing is they're replacing x with x plus 2 for g of x. So let's do that now. So there's g of x, but unfortunately we don't see this option in any of these choices. So we can approach this one of 2 ways. One, we know that this is the correct function and we can plug in these into Desmos and see which one is equivalent. Or 2, we can think of how to simplify this algebraically to have it equal one of these. So I'm going to choose the algebraic way first. I'm going to show you in Desmos how to do this as well. So remember, 4 to the x plus 2 is the same as 4 squared times 4 to the x. Now, why is that? Because remember, when you have the same base, 4 times 4, right? We're going to add those exponents and come back to this. So this is helpful because now I can simplify 4 squared as 16. So now I've got 9 times 16 times 4 to the x. 9 times 16 is 144. So I've got 144 times 4 to the x, which means B is the winner. But now I'm going to verify it for you in Desmos. So here's what we originally said g of x was, 9 times 4 to the x plus 2. And here's the answer, which was 144 times 4 to the x. And you see they overlap right on top of each other, right? And so there's your verification. Anyways, that's how you solve this. B is the winner. Done. In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? So what you have to recognize, and what makes this problem difficult, is you have to recognize that this is a quadratic, and you got to simplify it substantially before we can start to tackle it. So first I'm going to distribute that x, and I get kx squared minus 56x. Now it says equal to negative 16. I'm going to add the 16 over in one step and set it equal to 0. Now, why is this beneficial? Because quadratic having no real solution means the discriminant, if this is a, b, and c, the discriminant, which is b squared minus 4ac, must be less than 0, aka negative. So now we can plug and chug and isolate k. So b is negative 56 squared minus 4 times a, which is k, times c, which is 16, and all of this is less than 0. So now we just got to isolate, and we're going to probably need to use Desmos here because these are big numbers. So negative 56 squared is 3136, which means we have 3136 minus 4 times 16 is negative 64. k is less than 0. I'm going to minus 3136 from both sides, negative 3136. Then we're going to divide by negative 64, which means we're going to flip that inequality, and I'm going to calculate that in Desmos. 3136 divided by 64 is 49. So k is greater than positive 49. So the least possible value, since it's saying that k is an integer, it says k is greater than 49, meaning k could be 50. So 50 is the winner. Done. Two data sets of 23 integers each are summarized in the histograms. For each of the histograms, the first interval represents the frequency of integers, again, greater than or equal to 10, but less than 20. So what does that mean? This is integers from 10 through 19 because this is less than 20. These are integers from 20 through 29 and so on and so forth, and the same applies here. Just knowing this information says what is the smallest possible difference between the mean of A and the mean of B. So basically what this means is we need to get these means as close to each other as possible to get that smallest difference. So since all of these values are kind of lower, right, you see the same frequency of 10 to 20 as we have here from 20 to 30. So for this one, I want to get everything to be as high as possible, right? Because these are all lower. And for this one, I want them to be as low as possible because these are all shifted up to higher pockets, okay? And again, within these bounds. So that means all of these values in here should be 19, all of these should be 29, all of these should be 39, and all of these should be 49, right? We're trying to maximize those while trying to minimize these, meaning all of these should be 20, 30, 40, and 50. And this will give us the smallest possible difference between the means of these two. So since we have 3 of these, 4 of these, 7 of these, and 9 of these, we're going to multiply 3 times 19, 4 times 29, and so on to get that total. So it's that total, 887 divided by the amount of values, which is 23. And then for the second set, it's adding up to 910 divided by 23, which gives us a mean of 39.565. So you can see, looking at the two means, they're only 1 apart. That's as close as we're going to get them. So that means the smallest possible difference is B for the win. Done. The first term of a sequence is 9. Each term thereafter is 4 times the preceding term. So it'd be like 9, 36, 4 times 36 is 144, and so on and so forth. So W represents the nth term. Which equation gives W in terms of n? They're talking about the format for, or the formula for a geometric sequence, okay? The nth term of a geometric sequence, that explicit formula. And so the nth term of a geometric sequence, if we have W, is equal to the first term 9 times the common ratio, which is what we're multiplying by to get to each successive term, which would be 4 to the n minus 1. So the reason why I rank this as one of the hardest problems is because you got to know this geometric formula to do this quickly. Now, of course, you can plug and chug and be like, all right, well, I know if I plug in 1, I should get 9. If I plug in 2, I should get 36. You can kind of run it through that way. But anyways, that's why I classify it as such. So the answer here would be 9 times 4 to the n minus 1, which is D. Boom, done. The minimum value of x is 12 less than 6 times another number n, which inequality shows the possible values of x. So the reason why I think this one is on the more difficult side is you have to be very careful in how you set this up. So it says the minimum value of x, meaning x, if you're talking about a minimum value, it means x is greater than or equal to that, because that would be the minimum, right? It's x can be anything bigger than or equal to the minimum value. So x is greater than or equal to 12 less than 6 times n. And we have 6n minus 12 here and here. So the question is, which one is the correct answer? And again, recognizing that that minimum implies it should be greater than or equal to, we know that B is the winner. Done. The graph here is translated 4 units down in the xy plane. What is the x-coordinate of the x-intercept of the resulting graph? So I want to show you how to tackle this appropriately. You might just be like, oh, I just minus 4 from the right-hand side, but that's not how you're going to tackle this one. If we're talking about 4 units down, what you're going to actually have to do is say 9x minus 10 times y plus 4. Okay, so it's opposite. This means it's going to move down by 4, and this is equal to 19. So if I know that this is going to appropriately shift this down by 4, I can plug this into Desmos and find the x-intercept. So as you can see, here is the original function, and then as we add in that plus 4 like so, it does shift it down by 4, giving us an answer of 6.556. That's our decimal answer. Okay, the other way to do this algebraically, which might seem a little bit more logical or make more sense to you, is first get this into slope-intercept form, right? So I've got negative 10y. I'm going to subtract 9x from both sides, negative 9x plus 19. Then I'm going to divide by negative 10. Y equals negative 9 divided by negative 10, which is 9/10 x. That's just the slope. And then minus 19 over 10, right? 19 divided by negative 10. Okay, now we want to shift this down by 4 units. So what I'm going to do is I'm going to minus 4 here, right? Literally, now we can subtract 4. Now we're going to be good to go. So here's the original y-intercept. We're moving it down by 4. And this is the same as negative 40 over 10, right? So that's going to be negative 59 over 10, 9/10 x plus negative 59 over 10, or minus 59 over 10 equals y. And to get the x coordinate of the x-intercept, I plug in 0 for y. So plugging in 0 for y, I now have 0 equals 9/10 x minus 59 over 10. Now I can solve as follows. I can add 59 over 10 to both sides. This will give us a nice fraction value instead of a decimal from Desmos. Equals 9 over 10x. Now to isolate, I'm going to multiply both sides by the reciprocal, which is 10 over 9. Boom, boom. And my final answer is x equals 59 over 9. That's my x-intercept. And now you can see 59 over 9. I'm going to plug it into Desmos and show you that it's equivalent to the decimal answer we got from graphing. 59 over 9 is 6.5 repeating, which again is the same as this 6.556 that's just rounded up. So anyways, you could answer it as this fraction or the decimal. That's how you do it. Done. So here we have a quadratic expression where b is a constant, can be rewritten as this, which is factored form. And then it says that h, k, and j are all integer constants. Which of the following must be an integer? So what I see over here, as I'm going to start to factor this, is I see just a regular x, and then we have a standalone constant, right? And we don't know if j, k, or h, if they're positive or negative. It just says they're integers. Now over here, we have h, x, right? And since we know that this term is 4x squared and the product of these first two leading terms is going to be 4x squared, I know that h has to be 4. Now, if h has to be 4, I know that 45 over h is not going to be an integer, right? 4 does not go into 45. Another thing I know is that k times j, right? Those two integers at the end, k times j has to equal this constant at the end, negative 45, right? The product of k times j is negative 45. What this leads me to believe then is if I divide by k, right? J equals negative 45 over k. And since I know that j is an integer, negative 45 over k must be an integer, which means that regardless of the sign, 45 over k has to be an integer. That's how you do it. Done. So for this one, the rational function f is defined by an equation in the form of f of x equals a over x plus b, where a and b are constants. The partial graph of y equals f of x is shown if g of x is f of x plus 4, right? And again, this is f of x, so g of x is f of x plus 4. Which equation could define g? Now, by the way, f of x plus 4, I'm going to scroll down so we can see the rest of these choices now. F of x plus 4 means f of x translated 4 to the left, right? Plus, you might think right, it's actually to the left. So just to give you an idea of what that looks like, we're going to color code this in red. Here's my original point. The translated function g is going to be 4 to the left. This point here is going to be 4 to the left, and so on and so forth, so we can kind of start to see now what this would look like. Now, as we're trying to determine which function could be g of x, I already have two really amazing points, right? I have this point, which is negative 9, negative 6, and I have this point, which is negative 10, negative 3. That's enough to figure this out because I can just go through the options now, plug in these x values, and see which function is going to give me these appropriate y values. So if I plug in negative 10 here, obviously I'm not going to get negative 3, that's out. If I plug in negative 10 here, I get 6 over negative 6, which is negative 1, not negative 3, out. If I plug in negative 10 here, I get 6 over negative 10 plus 8, which is negative 3. Now plug in negative 9. 6 over negative 9 plus 8, which is negative 1. 6 over negative 1 is negative 6. If it works for both points, it's almost certainly has to be correct. Let's just check g just for fun. If I'm going to plug in negative 10, well, actually, in g, it's pretty obvious because these two essentially cancel out. So you're going to get 6 for every function value. That's clearly not going to give you those right y values. So anyways, that's how I would do this. Pay attention to what this translation exactly means. Plug and chug. That's how you do it. Done. So for this one, it says the product of the solutions to the given equation is KAB, where C is a constant. What is the value of K? This is a really difficult problem, especially with all these constants, unless you remember the nice little shortcut. And the nice little shortcut is as follows. The product of solutions of a quadratic, if this is A, B, and C, is equal to C over A, right? And what is C? In this case, I know it's confusing because I use A and B, but C is this term right here, which is AB over A, which is 57, is equal to, and then they also say the product of the solutions is also equal to this, KAB. Now we can solve for K, right? So first of all, I can divide both sides by AB to isolate, boom, boom, cancel. Those cancel, and K happens to be 1 over 57. So if you know that special formula, it's not too bad. So that means A is the winner, done. The graph of this in the XY plane is a circle. What is the length of the circle's radius? So first I'm going to show you what happens if you plug this in directly into Desmos. So here's the circle that we get, right? And it's a little tough to tell what the radius is because I can't see exactly where the circle is, but I do have a nicely defined top and bottom value. You got to be careful because it is showing us also these y-intercepts, but here is the top value, right, at 9.5, this bottom value at negative 10.5. So you can kind of see, right? The diameter, at least, is the difference of 9.5 minus negative 10.5. 9.5 minus negative 10.5 is the same as those two added together, which is 20, okay? So if that's the diameter, the radius is half of that, which is 10. That's the best way to do it via Desmos. If you did need to do this by hand, if you're not sure, if you got stumped, remember, you have to put this back into standard form by completing the square, right? That's kind of going to be a long process. You have to take half of the b term, square it, half of the b term, square it, add it to both sides. Actually, I'll run you through it just so you can see. So we have x squared plus x plus half of 1 is 1/2, squared is 1/4. Same for the y value, y squared plus y plus 1/4. And if we're adding it to the left side, we must add those to the right side. So it's 199 over 2 plus 1/4 and 1/4. 2 1/4 is 1/2. 1/2 plus 199 over 2 is 200 over 2, which reduces to 100. And by the way, on the right-hand side, this is radius squared. So the square root of 100 is 10. It gives you the same answer. So anyways, 10 is how you do it. Done. Two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square and the surface area of each prism is K. If the prisms are glued together along the square base, the resulting prism has a surface area of 92 over 47 K centimeters squared. What is the side length in centimeters of each square base? All right, so here are my identical rectangular prisms, and it says that they both have a height of 90, so let's write that out here. Now it says that each prism in total, right, the surface area is K. And the final question is asking, what is the side length of each square base? So we're going to call the side length of the base is X. So now what we're going to do is we're going to create an expression for the surface area based on this being X and X, right? So how do we get surface area of this prism, right? Well, basically it's each one of these 4 rectangles on the sides plus the 2 squares on the top, right? So and the bottom. So we got the square on the top, which is X squared. We got another one on the bottom, so that's 2. And then to get this, right, one of these, it's 90 times X, but it's 4 of those. So 4 times 90X is 360X. So this is what equals K. Now they say when they glue 2 of these together on these bases, right, what's going to happen if you put this on top of this? You're going to lose 2 of these X squareds, right? You're going to basically absorb those because they're going to be glued right on top of each other. So that resulting figure is going to now look like this when you stack them. And so we got the square base on the top and the bottom. So again, that's just 2x squared. And then we got the 4 going around, which is 360x, but then we have another 4 on the bottom, so that is 720x. And it says that this resulting prism is equal to 92 over 47 times k, but we already know that k is this expression, right? 2x squared plus 360x. And now we have an equation that we can solve for x, so let's go. So of course we could solve this algebraically, but I think the best course of action at this point, now that we have a great equation, is to leverage Desmos. So what I'm gonna do is I'm just gonna plug this in as is to Desmos and see what it gives us. Let's do that now. So here we go. I put in that entire equation and you can see these two vertical lines, which are gonna give me my x value. So this one is at 0. That doesn't help, but this one is at 8. And that's it. That means 8 is our answer. Done. In the xy plane, a parabola has vertex of 9, -14, and it intersects the x-axis at 2 points, just making a rough graph, right? Here's 9, here is -14, just approximately, and there's our point. And then it also says the equation is written as this, where a, b, and c are constants. Which of the following could be a plus b plus c? All right, so let's just think about this for a second. So it says it's opening this, or it doesn't say it's opening this way, but we can assume it is because it says it intersects the x-axis at 2 points. Okay. So if this is 9, right, and -14, we've got our vertex at 9, -14. Now, the fact that this is in standard form is cool because I know that -b over 2a always gives me my x value of the vertex. That means this equals 9. So the reason why this is great is because I can right away multiply both sides by 2a, and we get -b equals 18a, or multiply both sides by -1, b equals -18a. Okay, so now I can start to substitute some values in to simplify this expression. So we know a plus b, which I know now is -18a, and then we got to figure out what c is. So now as we simplify a little bit more, a plus -18a is -17a plus c. Now taking my vertex 9, -14, I can plug it in for x and y. I can also simplify this equation. I can make it y equals ax squared, and since b equals -18a, I can say -18ax plus c. We can do a little plug and chug now. So -14 in for y, 9 in for x. So now we get -14 equals a times 9 squared, which is 81a, and then 9 times -18 is 90 plus 72 is -162a plus c. 81 minus 162 is -81a. And just to isolate then, c equals -14 plus 81a. All right, so now we can plug this in over here and we get -17a plus -14 plus 81a. 81 minus 17 is 64. So last but not least, the expression is 64a minus 14. Okay. Now we still don't know what a is, but I know that a cannot be 0, right? If a was 0, this would be -14, but a can't be 0. We know it has to be positive because it's going up, it has 2 x-intercepts. So -14 is out of the mix. So now it's down to these 3 answers. But again, I know that a is positive, right? It can't be negative. So if a could be negative, then we could go below -14. But since a has to be positive, even if it's 0.0001, this value right here, this expression has got to be something positive. So there's no way it can go below -14. So -19 and -23 are out, but -12 is a possibility, which means D is the winner. Done. The function f is defined by this, where a and b are constants. In the xy plane, the graph of y equals f of x passes through this, and f of 24 is negative. Which of the following must be true? Okay, so first of all, we get this nice coordinate here, so I'm going to plug and chug this in for x, that in for f of x. So 0 equals a times -24 plus b. And in addition, if I look at this, right, I've got -24 comma 0, let's say right here. And it says that f of positive 24 is negative. That means it's down here. Now, if you remember, typically your square root function goes like this, but if it's going down this way and hitting a negative point down here, that means it's been flipped across the x-axis. That means a has to be negative. So a is less than 0. And if a is less than 0, right, a is negative, it can't be 0. That means in order for this equation to be true, it means this value must 0 out, meaning b has to be 24. All right, so if b is 24 and a is negative, it stands to reason, therefore, that b is greater than a, which means D is the winner. Done. The graph of the linear function y equals f of x plus 19 is shown. If c and d are positive constants, which equation could define f? All right, let me move this down a little bit. So the reason why this is interesting is because we have a linear equation, but this is not f of x, right? This is saying this graph, and this is where you have to be careful on these later problems in module 2. It's saying this is f of x plus 19. So the regular function, right? So this has, whatever this is, the regular function f of x is 19 down, right? Because this is 19 shifted up. So first of all, what is this function? We can actually calculate it this way, right? I can see I have a slope of down 4 over 1, meaning my slope is -4, and my y-intercept is 3. Okay, so that means my equation for this, which is f of x plus 19, is equal to -4x plus 3. But now to get f of x, I need to minus that 19, and that brings us down. So then I know y is equal to -4x minus 16. Okay, now it's saying that c and d are positive constants, okay? So since we know that we've got a negative slope and a negative y-intercept, we need a negative in front of both c and d, right? And obviously we know what c and d are, but they're not asking for that. So we need negatives in front of c and d, and I see that in option A, right? Because they're saying c and d are positive constants, so we need to negate them to get the -4 and -16, which means A is the winner. Done. In the figure shown, AB is square root of 34. Watch how I fill in the diagram. As I read, AC is 3, and CE right here is 21. What is the area in square units of triangle ADE? So that's what we're trying to find. So to get area, we do base times height, which I'll say is x, divided by 2. So we know it's 24x divided by 2. We just got to solve for x. So the cool thing here is we have proportionate triangles, and the reason why is because we have right angles here, and then this angle, which is included in this triangle, is also included in the big one. So that means we have angle-angle similarity and similar triangles. All right, now we can use this to potentially solve for this side and then get this side, or we could use Pythagorean's theorem, solve for this side, and then use a proportion. Actually, I'm going to do that. Okay, so let's solve for this side. We're going to call it y. And using Pythagorean's theorem, we got 3 squared plus y squared equals rad 34 squared. So that's 9 plus y squared equals 34. Subtract 9 from both sides. Y squared equals 34 minus 9 is 25. Square root both sides, and y equals 5. All right, so this side is 5. Now we can set up a proportion to get x. We can say 3 over 5, right? So little leg over big leg is equal to, for the big triangle, 24 over x. Okay, now we can cross multiply to solve. 5 times 24 is 120, equals 3 times x, divide by 3, and x equals 40. Now what we got to do is plug and chug. So we got 24 times 40 all over 2. 40 divided by 2 is 20. 20 times 24 is 480. So 480 square units for the win. Done. In the xy plane, a circle has center C with coordinates HK. Points A and B lie on the circle. Point A has coordinates of this. ACB is a right angle. What is the length of AB? Very difficult question. Let's draw it out. So here's the diagram. Here's AB. And as you can see, as I've drawn it out, it now looks like a right triangle. But moreover, since it's in a circle, these are equal, which means it's a 45, 45, 90. Now, since the center is H, comma, K, like so, I can actually calculate the distance between A and C, which will give me this length right here, and then I can use that to calculate x, which is the hypotenuse of this 45, 45, 90. So let's do that now. Distance formula is equal to the difference of the x values, so h plus 1 minus h, right? H plus 1 minus h. These are going to cancel out, which is just 1, and we square it, plus the difference of the y values, this and this. So it's squared, of course. So k plus rad 102 minus k. Again, these cancel out. Rad 102 squared is 102. Okay, so check this out. 1 squared, which is 1 plus 102, is 103. All right, so the distance here, or this length, is radical 103. Now, since this is a 45, 45, 90, to go from a leg to the hypotenuse, all I do is I take this and I multiply it by rad 2. Rad 103 times rad 2 is rad 206, which is option A for the win. Done. For an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field's strength, and the area of the surface. Okay, so that is the flux. A certain flat surface consists of two adjacent squares where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. So this would be x and this would be 3x. That means this area would be x squared because it's a square. This would be 3x squared, which is 9x squared. An electric field with strength 29 passes uniformly through this surface, which would be 9x squared plus x squared, which is 10x squared. And it does state that it's perpendicular to the field. That's a precondition that we need to satisfy, so it's satisfied. And then it says if the total electric flux of the electric field through the surface is 4640, what is the electric flux of the electric field through the larger square? So this problem is incredibly difficult, right? But slowly but surely we've broken it down, set up the right formula, and plugged in appropriately. So right now what we're gonna do is we're gonna solve for x. So I'm gonna do my straight up isolation, right? 29 times 10 is 290, so I'm gonna divide both sides by 290, and we get x squared is equal to, that divides perfectly to 16. And we take the square root, and we get x is equal to 4, okay? So now I'm gonna plug that back in here. This area therefore is 16. This one is 9 times 16, which is 144. All right, now coming back to our original equation, we're trying to find the flux when the strength is 29 volts and the area of the larger one is 144. Let's plug that into Desmos. 29 times 144 is 4176. So the final answer is 4176. A lot of careful reading, but you can then get to the answer nicely. That's how you do it. Done. The scatter plot shows a relationship between two variables x and y for dataset E. A line of best fit is shown. Dataset F is created by multiplying the y coordinate of each data point from the set by 3.9. Which of the following could be an equation of a line of best fit for dataset F? So my strategy here is basically I'm going to choose two nice points. How about this, my nice y-intercept, and maybe this point, which looks like, I don't know, 20, comma, if that's 45, that's maybe like 43. And we're going to multiply the y values by, it says 3.9, I'm just gonna say 4, okay? So again, my y-intercept looks to be like 0, 12, and that one's that. So let's multiply just the y values by 4. So now I'm gonna have 0, 48. And for this one, I'm gonna have 20. 4 times that is, what is that, 172. So now I got two nice points. I can just create an equation of a line from this and see which one of these is closest to it. So we're gonna subtract down first to get the slope. 172 minus 48, and that's 124. And then divided by 20 minus 0, which is 20. 124 divided by 20 gives us a slope of approximately 6. So the ones that have a slope of 6 are going to be A and C, right? Because 5.9 is pretty close. And by the way, the slope is the value in front of the x. So B and D are out. Now the question is, which one has the more appropriate y-intercept? Well, I already said the y-intercept is about 48, right? And that was approximation. 12 is clearly way off. So the new y-intercept and the correct y-intercept for this should be 46.8, which means A is the winner. Done. The function g is defined by this. The value of g of 7 minus w is 0, where w is a constant. What is the sum of all possible values of w? So what this means is when I plug in 7 minus w for x, and for x, I get 0. So let's plug that in. So x becomes 7 minus w. This one becomes 7 minus w, and a minus 2 still stays there. And this one becomes 7 minus w plus 6, and that's still squared. Now, as we simplify, we still have 7 minus w. 7 minus 2 is 5 minus w. 7 plus 6 is 13 minus w squared. And they said all of this is equal to 0, right? When we plug in 7 minus w. All right, so what is the sum of all possible values of w? Well, this is all factored nicely. Now we can get the values for w, right? 7 minus what is 0? 7. 5 minus what is 0? 5. 13 minus what is 0? 13. So these are the three possible answers. The sum of 7 plus 5 plus 13 is 25. That's how you do it. Done. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is this. What is the length of the diameter? All right, let's draw this out. So it says that if this is the shortest side of the rectangle, it says the diagonal of the rectangle is double that. So we'll call it 2x. And by the way, 2x is also the diameter, right? It's going through the center of this circle. And what you may recognize as well, rectangles, got to be a right angle, but when the hypotenuse is double one of the legs, right? This is a 30, 60, 90. It has to be. So this must be 30. This must be 60. And this side must be x rad 3. So this tells us a lot because now since we know the area of the rectangle is this, and this is one side, this is the other side of the rectangle, it means that x times x rad 3, meaning x squared rad 3, is equal to 1089 rad 3. Divide both sides by rad 3, kill that. X squared equals 1089, which means x is equal to the square root of 1089, which is 33. So x is equal to 33. Now, since the diameter is 2 times x, the diameter is therefore 66, and that is how you do it. Done. The positive number a is 2,241% of the sum of the positive numbers b and c, and b is 83% of c. What percent of b is a? All right, this is basically a system of equations. It's just using these annoying percentages, but let's turn them into equations. A is 2,241 or 22.41 of means multiply the sum of b plus c. There's my first equation, and then it says and b is my equal sign, 83% or 0.83 of means times c. Now I got this great system of equations. I need a relationship now just between b and a. So I want to get rid of that c, so I'm going to isolate c here. I'm going to say c is equal to b divided by 0.83, and then we're going to substitute this in for c over here. So now I've got a is equal to 22.41 times b plus b over 0.83. Now to simplify this, let's get common denominators. I'm going to say this b is 0.83b over 0.83, right? So now I got 0.83b plus 1b. Hold on, let's simplify this out. That is, so we still got the 22.41, and then we've got 1.83b over 0.83. Now we're going to simplify all of this 22.41 and all that. So let's do that in Desmos. And we get 49.41. So A is equal to 49.41B. So what percent of B is A? Well, we got the equation right here. A is 49.41 times B, which is 4,941% of B, which is D. Remember, it's not this. It looks like that, but it's not that because in equations, it's always the decimal equivalent of the percent. So anyways, D is the winner. That's how you do it. Done. The table shows 3 values of x and the corresponding values of g of x, where g of x is equal to f of x over x plus 3, and f is a linear function. What is the y-intercept of y equals f of x in the xy plane? So what we're going to do is we're going to do a little plug and chug to try and figure out what f of x is. So I'm going to just choose 2 of these points here. Let's choose these 2, okay? And we're going to do a little plugging in, right? So when x equals -9, g of x equals 0. So we got 0 equals f of x over -9 plus 3, which is -6. We'll multiply both sides by -6. And we get f of x equals 0. So guess what? I know that for f of x, when x is -9, the function value is 0. Now let's plug in 21 and 5. So when g of x is 5, I know that it's going to be f of x over 21 plus 3, which is 24. Multiply both sides by 24, and f of x equals 5 times 24, which is 120. So that means when x is 21, the y value is 120. So now I have 2 points. I can come up with the equation for this linear function f of x, right? So let's subtract down. Let's get the slope. 0 minus 120 is -120 over -9 minus 21, which is -30. -120 over -30 is equal to 4. And now using point slope, let's use the top equation or coordinate because it's easier. So it's y minus 0 equals to the slope 4 times x minus -9 or x plus 9, okay? And y minus 0 is just y, distribute, and we get y equals 4x plus 36. They asked for the y-intercept of f of x, which is right here, 36. A is the winner. Done. A circle has center G and points M and N lie on the circle. Line segments MH and NH are tangent to the circle at points M and N, respectively. If the radius of the circle is 168 and the perimeter of quadrilateral GMHN is this, what is the distance between points G and H? So if you don't draw this out, this is pretty much impossible. So we're going to draw it out really nicely, and then I'm going to show you how to tackle it. So here's point H, and we've got those tangents coming out and touching the circle. We've also got GM and GN that I want to draw on, and those are important because those are radii. The other thing to remember is external tangents from the same point are going to be congruent. So these are going to be congruent, as are these lines, because all radii are congruent. Now we also know that the radius is 168, so I'm going to write that in here. And last but not least, I'm going to connect G and H because it says that it wants that segment length. Now we got a great diagram. Now we can do this. One other thing though that we gotta put in and you gotta recognize is that this is a right angle. And the reason why is because when you have a tangent touching a radius of a circle, it's gonna form a 90-degree angle. Now since that's 168 and this is 168, we can calculate MH by using this perimeter, right? Because if I call this X and I call this X because they're both the same, that means 2X, right? X plus X plus 168 plus 168, which is 336, must equal that perimeter. So now we can solve for X. Let's subtract 336 from both sides. And we get 2X equals 3520. Divide both sides by 2 like so. And we get X equals 1760. So if X equals 1760, and this is a right triangle, we got the two legs. All we need is the hypotenuse. By the way, I know that the hypotenuse has to be bigger than the legs, right? So it's got to be bigger than 1760, so that means the only viable option is D. But I'm going to prove it for you using Pythagorean's theorem in Desmos anyways. So 168 squared plus 1760 squared is that number, and the square root of that number gives us 1768. So D is definitely the winner. Done. The function f is defined by this, so it's quadratic, where a, b, and c are constants. The graph of y equals f of x passes through the points 7, 0, and -3, 0. If a is an integer greater than 1, let me write that out, a is greater than 1, which of the following could be the value of a plus b? All right, so the first thing we can figure out, since I know the two x-intercepts, is that the vertex is going to be right in the middle of these two guys. Since I know that a is greater than 1, it's going up, so my vertex is somewhere down here, okay? And what's in the middle of -3 and 7? We got to take the average. -3 plus 7 is 4, divided by 2 is 2. So I know my vertex is 2 comma something. Now the reason why this is great is because I know that the x value of the vertex is equal to -b over 2a. So -b over 2a must be equal to 2. Multiply both sides by -2a, and we get b equals -4a. So already I can substitute in -4a for b. So I got a minus 4a, which is -3a. So I'm trying to figure out what -3a can be. Now, since a, it said, is greater than 1, right? It can't be -3. -3 would be if a was equal to 1, so that's out. If a is like, 2 or 3 or 4, it's going to get deeper into the negatives. There's no way it's going to be positive, because the only way I can turn a negative into a positive by multiplication is by multiplying by another negative. So 4 and 5 are impossible. It has to be -6. That's the only one that therefore could be the value of a plus b. So a is the winner. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining. I'll see you in the next video. Take it easy.